You've touched a tree before. You touched it and walked away. Something you could not see and could not feel started inside your body the moment your hand met that bark, and it was still going 7 days later. And the thing you touched is not what you think it is. The question nobody asks is why? What is a tree doing to your body without a single chemical pill? The answer involves what wood is actually made of, what is happening underneath every forest floor, and why the oldest living thing on Earth has never aged a single day. Hold your hand out in front of you. Look at your fingertips. You have touched thousands of things today: a doorknob, a coffee cup, your phone, the fabric of your clothes. You have never touched a single one of them. Not once in your entire life. The electron clouds around the atoms in your skin repel the electron clouds in everything you reach for. Electromagnetic force pushes back across a gap that never closes. What you feel as contact is force across empty space. Every texture you have ever known, every handshake, every surface you have pressed your palm against, electromagnetic repulsion. Your brain interprets the force as touch, but the gap is always there. So when you put your hand on a tree, your skin does not meet the bark. But something does cross that gap, not through contact, through the air between you. And the physics of what crosses that gap is the first thing nobody ever explains. Trees release molecules into the air around them, not occasionally, constantly. Constantly. These are volatile organic compounds, molecules with low enough molecular mass and high enough vapor pressure to transition from liquid to gas at ordinary temperatures and atmospheric pressure. That is a physics threshold, not a biology one. Whether a molecule becomes airborne depends on intermolecular forces, how tightly the molecules grip each other. Below a certain molecular weight and above a certain vapor pressure, the molecule escapes into the gas phase. Alpha-pinene, beta-pinene, D-limonene, 1,8-cineol. These molecules are light enough and loosely bound enough to float. They have a name, phytoncides, and that word does not mean what people selling essential oils want you to think it means. It was coined in 1928 by a Russian biologist named Boris Tokin, and it literally translates to exterminated by the plant. These are chemical defense weapons. Trees manufacture them to kill bacteria, fungi, and insects that threaten the tree's survival. The tree is not releasing pleasant aromas. It is waging chemical warfare on everything small enough to be destroyed by airborne molecules. Here is the physics that matters. Once these molecules enter the gas phase, they follow the same rules every gas follows. Fick's law of diffusion. Molecules move from regions of high concentration to regions of low concentration along a gradient. The tree is the source. Maximum concentration at the bark surface. The air around the tree is the gradient field. Concentration drops with distance according to an inverse relationship. 1 hectare of pine forest, about 2.5 acres, releases roughly 5 kilograms of phytoncides into the air every single day. 5 kilograms of antimicrobial molecules diffusing outward, sterilizing the atmosphere as they go. Forest air contains 200 to 300 bacterial cells per cubic meter. City air contains thousands. The diffusion field around the tree is, in a measurable sense, a sterilization zone. When you stand near a tree, you are standing inside this diffusion cloud. When you touch the bark, you are at the point of maximum concentration. Your lungs pull roughly 6 to 8 liters of air per minute at rest. Each breath carries these molecules across the thin membrane of your alveoli and into your bloodstream. The physics is simple: gas phase diffusion into a low-pressure biological system. The consequences are not simple at all. Once these molecules cross into your lungs, something measurable happens. In 2009, a research team led by Dr. Ching Li at Nippon Medical School in Tokyo exposed human subjects to phytoncides and measured what happened to their immune cells over the following weeks. Natural killer cells. A specific class of lymphocyte whose function is to identify and destroy tumor cells and virus-infected cells, showed significantly increased activity. Not for hours, not for a day. The increase in natural killer cell activity lasted more than 7 days from a single exposure. Extended exposure over 2 or 3 days in a forest produced effects lasting more than 30 days. The same studies measured adrenaline and noradrenaline concentrations in subjects' urine and found significant reductions. The stress hormones that drive your fight or flight response physically decreased in the presence of these diffusing molecules. Think about that. Molecular compounds following a concentration gradient through an air gap entering through the respiratory system and altering the behavior of specific immune cells for weeks. Not relaxation, not fresh air, not placebo. Physics, diffusion physics, delivering a measurable biological result. But there is a second mechanism operating through the same tree at the same time: electron transfer. A tree is an electrical conductor. Its root system is in direct contact with the Earth's surface, which carries a net negative charge, a charge maintained by the global electrical circuit driven by roughly 2,000 active thunderstorms happening at any given moment around the planet. When your conductive skin contacts a grounded conductor, charge flows. Electrons move from the Earth through the tree into your body. A study published in 2013 measured what this does to human blood. Grounding increased the zeta potential on red blood cells, the electrical charge on the cell surface that determines how strongly cells repel one another. Higher zeta potential means your red blood cells spread apart rather than clumping. A measurable change in blood viscosity from electron transfer through a tree trunk connected to the ground beneath your feet. There is a third layer, and this one is a trick your own nervous system plays on you. Thermal conductivity. Wood conducts heat roughly 1,000 times more slowly than metal. When you wrap your hand around a metal railing on a cold morning, the metal rips heat from your skin. It feels freezing. Wood does not do this. Your hand stays warm, and your brain reads that warmth as comfort, as the object giving you something. But the tree is not giving you warmth. It is simply failing to take it. Your nervous system cannot distinguish between an object that provides heat and an object that does not conduct it away.